So we're in Module 1 again this week. The lecture is already out here. This is the detailed lecture for this unit. So I would watch that and make sure there's a lot of little gotchas and things that might unlock the what the heck are we talking about in your mind. So make sure that you watch that. I have an example solution. Let me pull that up. I think that looks something like this. Does that look familiar to everybody? If you've clicked on that link and seen this, I basically give you a sample assignment. I analyze it the way I would like for you to analyze these problems that I assign. I do the pseudocode, I do the flowchart, and I do the Python. So if that was the assignment, and you did this analysis correctly, and you turned in this as the results of your assignment, you uploaded those to Canvas to submit them, you'd probably get close to 100%, assuming that I didn't do anything wrong that I would count myself off for. Okay, so trying to be helpful and give you a pattern and an example. You know, many of you I expect have never written software before. That's why you're here. And so I'm trying to give you an example to follow. You know, lots of these classes like this are follow the leader until, oh, I see what we're doing now, it's starting to make sense, and then you can start extrapolating from those patterns and doing it your own way. But in the meantime, here's how I would like for it to be done. Make sense? Okay, hopefully you've already clicked on that. And that's an example of the kind of resources that are out here to help you try to get started. So don't skip any of the steps, is my recommendation. Or, as a friend of mine used to say, dial your own level of pain. You know, you're adults, you can make your own choices, but then you have to live with the consequences. Dang it. Just brief little aside. I don't know if anybody was watching the Starship launch a few minutes ago. About 20 minutes ago, they launched Flight 7 and it made it to orbit. I had to run down here so I didn't get to see whether they were also supposed to deploy the little dummy Starlink satellites this time, for the first time out of the Starship, and I didn't see whether that was successful or not. But they caught the booster again, so that's the second time they've caught the booster, so I guess that part's repeatable. It wasn't a fluke the first time. Anyway, if you're curious about space type stuff like I am, there you go. Okay, so like I said, you can watch the lecture, you can read the chapter. That'll give you all the background information, the details that you need to know. You've got my example solution that you can refer to for how is this supposed to look before I turn it in. So hopefully you won't miss any of the points on Module 1. I'll reiterate, Module 1 is basically follow the leader and get familiar with the tools so that when we get to much harder problems, much more confusing concepts, you're not still trying to struggle with Thani or Flowgorithm and figure out how those things even work, because you've already done those with easy examples, and that way, you know, we can start scaling up from there. That seems to be the way that has produced the most success with previous classes, so that's the way I'm doing it this time. Okay, so you've got an assignment for Module 1, calculating discretionary spending. So clearly, well, maybe not clearly, I'm not going to do that one that is your assignment in class today as an example, because I want you to think about it. I want you to write the code yourself. But I'm going to do another sample program today. It's not going to be very complicated, but it's going to use a lot of stuff that you haven't seen, that we haven't talked about yet, just kind of throwing stuff on the wall, seeing what'll stick, so that one of these days, you know, in the next few weeks, as you see it in the book, you see it, you know, in the lecture, in detail, you will already have a little bit of a framework for it because you've seen what that does before once, okay? So the only goal for now is just to kind of watch and try to understand and ask questions if something just looks too bizarre for reality to you. Okay? All right, so here's my Thani. And let's see what kind of fun program we can come up with. Zoom in a little. So naturally at the beginning of our program we're going to put some comments in. Comments start with a pound sign, hashtag, whatever you call it, number sign, whatever you call that symbol. So I'm going to say name, my name is Mark, so you'll put your name there. Class, COP 1000, what are we section 103 or 101 or 102 or something, 100? 101? Okay. That just helps me out because I don't always remember which one of the classes you're in. So if you can just put that, that'll be great. And then I always like to think about what my program is going to do and print a nice little heading, a title. I always thought it was really cool. Let's see if I can show you an example. Let's just do the dir command. Dir. If you do the dir command, it displays this little title thing. Displays a list of files. That's not a real good example of one. Ping. Yeah, that's not a good example either. But they give you a bunch of information. Trying to find something with a good version. Okay, again, just a little line at the beginning of it to tell you what the program does. So not very good examples, but what I like to do is, so I'll put a comment to say I'm about to print my headings for my program, and then a print statement, and we always put what we want to print inside the parentheses. What I want to print is just a literal string, so I'm going to put double quotes, and then inside the double quotes I'm going to type something like, this is a cool program version 1.0 by Mark. If I ran it right now, let's see, desktop, sample.py. If I run it, it just prints that literal string that I wanted it to print. Okay? Then I want to also put a blank line on the screen just to give myself some separation. Oops. So I print blank lines by using the \n character in Python. There's a bunch of other characters, like \t is for a tab, and there's a whole bunch of them. So you can Google for string special characters, and you can find out what they are. You can print different symbols. Like one fun program is to print the clubs, diamonds, spades, hearts symbols for card games. That's kind of fun sometimes. Okay, so now I've got headings followed by a blank line. Then, okay, so now I've got to think about what this program is going to do. What I want to do is ask the user if they like cats. Also ask the user their age. Then I'm going to do some logic to determine if user is an old cat person. Okay, so I'm going to do some if statements. I'm going to do some interrogating of the values that they put out, and I'm going to do some print statements. So anytime I say ask the user for something or get this from the user, those are input statements. My program is getting input that it needs to do its work. So what shape are we going to use in the flow chart for the
rectangle?
the rectangle, kinda, but it's leaning. Yeah, the parallelogram is the input and it's also the output, because why make it easy, right? So input and output statements, input statements and print statements both use the parallelogram symbol on the flowchart. Then the do some logic to determine something, add the numbers together, see if the number is odd or even, all of those kind of things where your program is supposed to do something complicated. That's the calculation or the computation part of our program. And then the final part is once we do that, we want to print messages about the user telling them that they're an old cat person, So that would be our output. So again, we use the parallelogram symbol for those. So, it's not that complicated of a problem, but it's got some interesting things that we've got to do, and that's the point. So to get user input, ask the user if they like cats. One pattern that I like is to just, we need a variable. So you have to think about a name for the variable. And, I've been in modes where, I don't know why, but it's like writing the programming logic and coming up with the name for something must use completely different parts of the brain. Because I can be sitting there typing, 100 words a minute, blasting out code, and then all of a sudden I come to the line where, okay, I got to think of a variable name. And I just sit there and stare at my screen with writer's block for a few minutes. So that's normal. But I want a variable that contains the answer to the question, do you like cats? So how about likes cats answer? That's my variable name. And notice how I named it. I started out with a lowercase, then the first letter of each word is uppercase. Does anybody remember what kind of casing that is? There were a couple of different ways of upper and lower casing your names of stuff. This one is called camel casing. Does that make sense? So the camel has humps, so this is what we call camel casing. So then I'm going to get user inputs. I'm going to use the input keyword in Python. And inside the parentheses, just like the print statement outputs a string, I'm going to put a string inside here, which is what the computer is going to print in order to ask them what they're supposed to enter. So I'm going to say, do you like cats? Now, I like in my prompts, I could just leave it like that, except that they don't know how to answer. Are they supposed to say yes? Are they supposed to just hit the enter key for no? They don't know. So I'm going to give them a little help. I'm going to say Y or N for yes or no. So it's just a suggestion for them so they know what to enter. The next thing I'm going to point out is, see how the double quote is right after the end of my message? So this is literally what it's going to print on the screen. But if they do that, then when I start typing, there's not going to be any spaces between the parenthesis and what I type. So what I like to do is before the end of this string, I like to just put an extra space in. Just a little best practice for you. If you put a little extra space in, then when you run your program, it'll look a little nicer. Okay, so if I run that, then whatever they say, if they type Y or type N or type 47, whatever they type in and hit enter, that's going to be put into my variable likes cat answer. Well, I need to know whether they like cats or not, yes or no, Boolean, true or false. And so I need another variable. I'm just going to call it likes cats. And I'm going to set this to true if they entered a Y. I'm going to set it to false if they entered anything else. That's another one of those little programmese things. I don't have to make sure that they entered no for no. I can just make it kind of restrictive. Like, look, if you want to go on with a yes answer, you have to enter exactly what I'm looking for. Anything else I'm going to interpret as no. Does that make sense? A little computer logic trick there. So I'm going to say if likes cat's answer is equal to a Y colon, and then I indent because I only want this line to execute if that one was true. Likes cats equals false. So what I did just there, I would call that validating the user input and interpreting it so that I can use that later in my program. I probably could have done this half a dozen different ways. This is just the first way that popped into my head to do it. It's not a bad way to do it. You might come up with others that you like better, but this one works. So to break this down a little bit, and the lecture we're talking about expressions, operations, data types, things like that over the next, the first and second chapter. Whenever I want to ask if something is equal to something, I have to use two equals. Because like this line says, take whatever they enter and assign it to the variable. So one equal sign is an assignment statement. Two equal signs says, is it equal to? That's how you read those symbols. They're completely different symbols in Python. One equals versus two equals. Okay? That can be confusing to people when they're starting to learn program. The good thing about it is if you learn to tell those apart now, it's the same in Java, it's the same in C#, so you'll be set up for success down the road if you learn the difference between those. Just read this as an assignment. When I read this line of code on line 9, it says to me, set the variable likes cat answer to what the user inputs on the screen. That's how I would read that. The next one says, if likes cat answer is equal to Y, then set likes cats equal to false. You notice how I read this one, set likes cats equal to the value false. So it's another assignment statement. Okay? All right, so moving down here, I have another statement I want to say, ask the user what their age is. So it's going to be another input statement, right? I have to come up with another variable name. How about user age answer equals int. I'll do this the long way just to be very clear about what's happening. User age answer equals input again. Inside the parentheses, I want to put what I'm going to ask them, which is a string. I'm going to say, how old are you? I don't have to really suggest an answer for this one because age is kind of assumed to be a number, right? So they would expect to enter a number on this one, so that was pretty clear. But notice I did put the space after the question mark again. So before the double quote, make sure you put the space there. Okay, so now I have their answer. They typed in, 47, whatever. When you are watching the lecture, reading the book, looking at data types, the input statement only deals with strings, character data. Just like the print statement only deals with strings. And so what I get back from this user age answer variable is a string. And I can't do numeric computations with a string. The computer doesn't know how to do that. It has to convert it to an integer data type, a numeric data type, before I can process it. So just like on this one, I processed the answer that I got from the user and got the value into a form that I like. It's either going to be true or false. I'm going to do the same thing here. So now the user age equals, I want to convert something to an integer. And so that's how you take a string and convert it to an int in Python. I'm hoping, have you guys seen the examples of this in the lecture already, or haven't gotten to that yet? Okay, that's fine. Because like I said, my intention is just to throw stuff on the wall and see what sticks. You can always review this and watch the lecture again afterwards. Okay, so now we've got a Boolean, true or false, if the user likes cats or not. And we've got a variable that says how old the person is as a number. Great. So now we can do our logic. I think we've got the input we need. We can do our logic. Okay, what's the logic we want? We want to know whether the person is an old cat person. Well, are they old? Maybe we could ask them, because I don't want to be mean here. Ask the user, how old is old? So, user old answer. How old is old? Is old age equals, convert it to an int, user old answer. Okay, now I can do some logic. So I got two things. Are they old and are they a cat person? Right? I got a combined expression to create here. So there's several ways that I can do this. Like I said, I'm just going to pick the way that comes off the top of my head here to start with. And the way that I think I want to do this is, first I want to say if the user age is greater than is old age and likes cats, oh wait, I had this backwards, don't I? It's okay for you guys to say, hey, I think you got that wrong, right? If they said yes, that means they do like cats, right? So, yeah, I want that to be true. All right, so we saw an if statement here, and I'm putting another if statement here. And I don't know if I mentioned that up there, but one of the things to realize is what you put inside your if statement, it starts out with the word if, it ends with a colon, and everything inside here is a condition, an expression. Okay? So that's an expression that has to be evaluated by Python to come up with true or false. Is this if statement going to execute or not? So I'm just going to say, is what's in this variable greater than what's in this variable? and is in what's in this variable equal to that value. And that's how you do a complex expression to use in an if statement. So if that's true, then I want to print something. Else, if, let's say they're just old. I'm kind of making this up as I go. So the first one is if they're old and they like cats. The second one is just if they're old. Then I want to print something else. And if they're neither, then I want to print something else. And I want to be nice. You know, I don't want to be mean. So you're just an old cat person. I guess I had my sister in mind when I was coming up with the idea for this program, because my sister's got like 3 cats. And I make fun of her. It's like, you know, you're getting kind of up there in age. People are going to think you're an old cat lady. But I like cats, so I guess that would apply to. I just don't have any. So if they're just old, but they're not a cat person, then I say maybe you should get a cat. And then so if they're not a cat person and they're not old, I'll say, hey, maybe we should go get a beer then. Okay, did anybody fall completely off the map? Did I just totally blow anybody away? And you have any questions about any parts of that? Why did you do that? That doesn't make sense to me. What I typically hear is, oh yeah, well when you type it up there exactly the way it's supposed to work, it looks like it makes perfect sense. But then when I'm staring at a blank screen and I'm supposed to solve the problem that you gave us, that's when it breaks down. That's perfectly okay. Yes?
So you mentioned like down I think it's 24, where you mentioned right there. How come it's elif instead of blank?
Excellent question. So when you start reading about the way if statements work in Python, so let's say I didn't do this part. I could have just done that. If they're old and they like cats, they're an old cat person, any other condition, let's go get a beer. I could have just left it at that. That's simpler, right? If you want to ask some other condition other than just if the expression is true, do this, else do this. If you want to ask another question, you have to use elif, so that, because else doesn't expect a condition here. Like I can't say else true. What do you mean else true? It doesn't understand that. So if I wanted to ask another question, I have to use a different keyword. So elif expects to get another expression there. Make sense? So I'm just helping the compiler understand what to expect. And this is just keywords that you have to learn about Python. You know, if you were learning C#, you'd learn different keywords. So this is just Python specific stuff. Good question. Okay, what do you think? Can we run it? Do you think it'll work? Anybody see any broken pieces, any typos or anything I did wrong? Let me ask you, why didn't I put a space after the end of these literal strings? Yeah.
Because you don't have to put an answer, it's just kind of...
Exactly. Okay, yeah, so let's run it. Okay, here's my program output. I can make this bigger. Okay, a cool program, version 1.0 by Mark. Do you like cats? And it's waiting for my user input. So I'm going to say yes and press enter. Now it says, how old are you? Say 59, enter. How old is old? Like I said, I don't want to hurt their feelings. How about let's just say 40 is old? Well, you're just an old cat person. Okay, now this is another thing that I want to point out, and that's the reason why I wanted to use more complex logic than you're going to be doing on your first assignment, is that I tested it with one set of data. I would say I'm probably not finished testing because there are a lot of complicated stuff going on there. I would like to at least see each of my output messages on the screen once. So I need to come up with a second test case. So let's run it again. Do you like cats? Yes. And now I'm going to say an age that is not old. Okay, maybe we should go get a beer. So now, is that correct? Yes. Because they're not a cat person and old, so we can go get a beer. It has to be both, right? Because I said and. Right? I did that a little quick. What I should have done is paused for a moment. Do you like cats? No. How old are you? 65. How old is old? 45. Now before I hit enter and go into the calculations, what I'd like to ask myself is, what do I expect the program to do here? Because there's a psychological thing when programmers test their own code, that the output that they see, oh yeah, of course, that's what I expected to see. Your bias is to agree with what the code does because you wrote the code. So obviously it's correct to you. Okay, so if we take the other approach and I say, first, before I see what the computer does, what do I expect it to say here? The person's not a cat person, but they are old. What do I expect the output to be?
You should get a cat.
Maybe you should get a cat. Okay, let's see if it does it. Ooh, I've got a bug. Likes cats? Oh, yeah, so this is okay, good teachable moment. This is a logical error. It says the name like cats is not defined. Well, what do you mean it's not defined? It's right there. This is a little trick of logic in programs. If I come down through this program, it executes line 5, it executes line 6, it executes line 9, gets a string back, and then it executes the if statement. If this expression is true, then it executes this line of code on line 11. But if this expression is false, it never sets likes cats to any value. And that makes computer programs very unhappy. Anytime you look at a variable like we do down here, it says you never set that to a value, so I don't know what you're talking about. So I could say, there's two ways that this is often dealt with. I could say else likes cats equals false. Now it sets it to a value either direction. Does that make sense? Another way that I can do this, notice how I had to add 2 lines of code to do that, and programmers are lazy. I could set it up here. So now it's set to false, but wait a minute. It's set to false. How do I know that they didn't say yes? Well, it doesn't matter, because then I check to see if it's yes and set it to true if it's true. So let's choose your poison. In this way, I'm setting it to false, then setting it to true. Seems a little wasteful, right? But the other way takes 2 lines of code instead of 1 line of code. So which do you think most programmers are going to pick? The one that executes 2 lines of code, or the one that they have to write 2 lines of code? Well, like I said, the tendency is programmers want to write less code, so they probably do that. But what they should do if they want higher performing programs is do the one that doesn't execute 2 lines of code. So, but we'll leave it like this since that's the last way I typed it. So that was just a bug that I found while testing my program. And if I had stopped with that first test case and said, hey, it worked once, ship it, then it would have gotten out there to the customer and would have had this bug in it. And then they're going to wake me up at 2 in the morning, and I don't like that. Okay, let's use the same input. Do you like cats? No. How old are you? 65. How old is old? 45. And again, I expect to get the, maybe you should get a cat answer. Yay. So now I've seen all 3 of my outputs, and feel like I've probably tested it pretty good. Maybe there's a couple other cases I could throw at it just to play around and, hey, it's a cool program. It's fun to play with, so maybe I'd run it a few more times with different answers. And if we were trying to do serious testing, we might pick really weird values like -1 for the age and, 8 billion for the age or something like that to see if we could break it, But we're doing happy path testing right here, so that's probably good. Yeah, so I feel pretty good about this program. It does some nifty stuff and produces some output. Okay, yeah, so this is more complex than the programs you're going to be writing for the first module and probably the second module, okay? This is way more complex than those. So if you were roughly able to follow what we did here, maybe you couldn't come up with it on your own with a blank sheet of paper, that's fine, but you'll probably be okay for the first program. Another thing that you're going to see, and I'm going to throw it out here just because it'll be in the lecture video and you can go back and watch it later if you want to and have another example of it. Often what we do in programming is we say, keep doing this until the user says that they want to quit or that they don't want to do this anymore. Okay? And there are several patterns for how to implement that you'll see in one of the lecture videos. I forget which one it is. But it's very common. And the pattern that I'm showing you here is how I would like you to approach that, where get it working once first before you worry about any of the keep asking the user for their input until they say they want to quit. Okay? It's so much easier to do it this way where all of the hard logic is figured out, and then you go back and try to make it where they can keep doing it over and over and over again. So right here in the middle of my program is where I'm going to do this. Ask for input until user says they want to quit. And I'm only going to pick one of them because, like I said in the lecture video, it goes over all the different patterns for how to do this. So that is a loop. And like I said, it'll probably be a few weeks before you get to talking about loops. So just follow along and, this is a different thing. So we've seen input-output statements, we've seen if statements, and now we're looking at loops, loop examples. So similar to the if statements, we're going to keep looping while a condition is true. So we have to put some kind of an expression here. I could say while true, or I could say while 5 is equal to 4. I could put whatever expression I want in here, and it'll keep looping while that's true. What is it going to keep looping? What is it going to keep repeating? Anything underneath this while that is indented. Okay, so if I say while true, print 5, this is an endless loop, and it will keep printing 5 forever. So bear with me here a little bit. Remember how I said I'm going to set likes cats equal to false, and then if they entered a y, I'm going to set it back to true? I'm going to follow a similar pattern here. I'm going to say keep looping equals true. Then I'm going to say while keep looping equals true, which, okay, yeah, why wouldn't it be? I just set it to true, so obviously it's going to keep looping. Okay, print 5. You can interpret this as do something repeatedly. This is the do something part of your program, of your loop. Then at the end, I need to do something to give myself the opportunity to stop looping. I have to change the value of keep looping potentially, or otherwise it's going to keep looping forever. So to do that, I'm going to say keep looping answer equals input. Do you want to go again? Space, double quote, parenthesis. Then I'm going to say if keep looping answer is equal to a y, keep looping equals true, else capitalization is important. Keep looping equals false. And that right there is my whole loop. If all I wanted to do repeatedly is print 5. If I ran this program now, it would print 5 and then say, do you want to go again? I say yes. It would print 5, say, do you want to go again? I say yes. It'll print 5, do you want to go again? It would just keep doing that over and over and over again until I enter something other than yes or y. Then it'll set keep looping to false. It'll go back around to line 10. Keep looping is false, so it exits. Where does it exit to? And does it power off my machine? Does it close Thani? No. All it does is it exits this loop. So it jumps down to line 19 and starts doing whatever comes after the loop. Make sense? Now I've got a problem because this is all out of order. First of all, I don't want to print 5 every time through the loop. What do I want to do during the loop?
They want to go again.
All this stuff down here. So, I guess I don't need this comment because I did that in here. Yeah, all this stuff down here that I already had working, that's the stuff that I want to do repeatedly. So I'm going to move that up here where the do something repeatedly goes. And then I have to indent it. It wasn't indented before, so I have to indent it. Now it's inside the loop. Okay, does that make sense? It looks really complicated now that you see it all together, but all I did is I took something mildly complicated and I put it inside the loop. All the stuff about keeping the loop going is like a completely separate set of logic from the stuff inside the loop. And that's very common. Let's see if it works. Do you like cats? Yes. How old are you? 55. How old is old? 30. You're just an old cat person. Do you want to go again? Yes. Do you like cats? No. How old are you? 66. How old is old? 55. Maybe you should get a cat. Do you want to go again? No. Boom. And then there's one other thing missing, which is at the end of my program, I like to do a print statement. Thank you for using my cool program. And the reason why I usually ask you guys to put a print statement like that at the end is because of indentation. I want you to pay attention to your indentation. All the stuff from line 12 down to line 40, the end of my loop, that's all indented because it's supposed to be within the context of the while statement. But this print statement out here goes back to the left. It's unindented because it happens after the loop exits. What I see lots of people do is, hey, we're indenting, and then they indent this. What's that going to do, logic-wise? Now I've put it inside my loop, so it's going to print this every time through the loop, right? So I don't want that. I only want it to print one time at the end. And I could do some other stuff in here, like I could clean up the output, like put a print of a blank line here and there. I could tweak around with it. That's what testing is about, testing and refining and playing with it until you're happy, that sort of thing. But none of that's important to getting full credit to the assignment. You want the logic correct, you want to get the inputs, you want to do the correct processing, you want to produce the correct outputs, and then you can sit back and tweak it and make it pretty and stuff. Okay, any questions about the loop part? And I will tell you again, almost every one of these lines, there's half a dozen other ways I could do it. There's multiple ways. If you're out there Googling and you're looking at Stack Overflow and you're looking at your buddies, stuff, there's all kinds of different ways to do it. All I'm doing is showing you a way to do it correctly. This works. It just happens to work, right? But that's a great thing about programming is it's an artistic exercise and you get to express yourself using this flexible language. Your prompts will look different than mine. You might say yes and no instead of y and n. That's all perfectly fine. I could change this to say if likes cat's answer equals y or likes cat's answer equals uppercase y. Maybe either one is fine. I could play around with it and do all kinds of different stuff. But this does work. It happens to work. And that's the main thing that I wanted to go over tonight and make sure that you had an example to refer to for how to do one of these really complicated programs. This is about as complicated as our assignments this semester are going to get. So if you can understand everything I did here, it's the second week of the semester, right? That's it. You know where we're headed by the end. It's just that now you have to do it. You have to do it successfully and get it to work and test it, refine it, turn it in, and move on to the next one, like half a dozen times.